From the Spec Network, this is Fragmented, an Android developer podcast where we talk about building good software and becoming better Android developers. I'm Donn Felker.
And I'm Kaushik Gopal.
Welcome to the show.
Donn, we are back again. We've been off and on, but we have some very interesting stuff that we want to chat about. How you been?
Been doing good. I'm glad to actually get back on the phone with you. It seems like it's been a very long time. And I know the listeners have been wondering where the show is at, so I'm glad that we're going to be back for them. And again, to everyone who's been there listening, thank you for listening and staying there with us. Yeah,
it's conference time, but we've been running about here and there. It's been interesting, but yeah, we're back and we have some exciting stuff. Donn, do you know what we're going to talk about today?
I have an idea, but I'm not really super well versed in it. And I know that you found an individual that we could chat with that might be able to help us. So I won't really let the cat out of the bag. I'm going to let you do that here.
So this is a topic that both of us know that we've always liked because it helps with clean code, something we're a fan of. But like you said, we want to get someone who is really good at this stuff. And yeah, we just had the questions. So without further ado, I want to welcome Manu Sridharan. Hey, welcome to the show, Manu.
Thanks, Kaushik. Very happy to be here.
So for folks who haven't heard of you before in the Android community, could you maybe give us a quick gist as to who you are, how you started on Android, where you work?
Sure thing. Yeah. So I work at Uber right now on building static analysis and other kind of compiler tools with a team of great folks. My background is kind of from the academic world. I got a PhD and then worked in research labs.
Oh, nice.
Yeah, at IBM for a few years, at Samsung for a couple of years. Then I decided, it was time to get a real job. But there was this cool opportunity at Uber to, start taking some of the stuff that I'd been working on in static analysis and, bug finding tools and try to, really, have some good impact. And in terms of Android, it made a lot of sense to focus on Android and iOS when I started, because when you've got an app that's crashing, it's actually not that easy to get a fix out really quickly to your customers.
You wouldn't say.
Right. So, you can fix your code locally, but that's the first step of a long process, right? You've got to get it uploaded to the App Store. People have to actually update their apps. It can be weeks before you see a crash rate really go back down to zero. So the more you can do to prevent those crashers before your app ships, the better.
So that's kind of one of the reasons we really wanted to chat with you here, because crashes, we all use various different bug reporting tools, but as soon as you see a crash kind of spike up after release, it's usually your team that's, alerted whoa, we got to fix something here. And it's always one of those things how can we limit these types of crashes, or how can we limit this stuff from happening? And it seems you have quite the background in static analysis. And so I'm kind of wondering maybe if you could break it down for the folks that are listening that don't really maybe know what static analysis is, if you could break it down to almost explain it like I'm 5, what is static analysis and why is it good and so forth? And what does it do?
Right. So static analysis, you can think of a static analyzer as a program that's looking at your program, like your code as input, and trying to automatically figure out things about what it's going to do when you run that code.
Okay.
What's going to happen. So for example, an analyzer could, look at some Java code and say, hey, this code is going to take this null value, pass it into this other method, and that method is going to dereference it, which is going to cause a null pointer exception. The key thing is that all this kind of analysis should happen without actually running the code. So this is in contrast to something like testing or dynamic analysis or fuzzing, where you execute the code and you try to sort of observe what's happening. In static analysis, you're trying to figure all this stuff out, but without running the code at all. So that's a sort of very high level idea of what's going on. And it's kind of super broad, that definition. And I think that encompasses stuff from, say, linting, which is, can be as simple as just grepping for bad code patterns, all the way to kind of really advanced researchy stuff where you're trying to simulate as many of the different paths through your program as you can and really figure out at a very detailed level what exactly it's going to do. So I'd say that's like a quick overview of static analysis.
When you say static analysis, we're not running the program, but is the static and analysis tools that are out there or the programs that do this, are they actually looking just at my Java files or my Kotlin files, or are they looking at the bytecode that's resulted from compilation?
Yeah, that's a really good question. And I think there are tools that do one or the other. So again, there's a wide variety there. There are plenty of tools that look at your Java and Kotlin files. I'd say, but one thing they do is they usually do some of the work, at least, that a compiler would do.
Okay.
So
Got it.
like if you have a name of a class, it'll actually try to figure out what class is that actually referring to, and you have easy ways to figure out, what are the superclasses or interfaces that one implements, that kind of thing. So it's not just treating your code as a piece of text. Most at least reasonably sophisticated analysis tools do work to figure out, when you see a name, what does that refer to? What's the type hierarchy of your program? That kind of thing. But then there are tools that work just on bytecode. There are even tools that work on binaries, and they don't even care what compiler produced this binary, and they start trying to analyze the assembly code and figure out what's going on there. That tends to be really hard. This is for people that are, trying to figure out if there's some kind of malware in this binary. And, when you get a random binary off the internet, if it's a hacker, maybe they weren't too cooperative in terms of how they set things up to make it easy to analyze. So
Kaushik.
So it, it can really span the spectrum. I think most of the tools in the Android world that we're familiar with, though, do work at the source code level. And one nice thing about that is that it's easy to give good error messages because you've still got the source code there.
It seems like static analysis tools spans the whole spectrum of when you do it. So it's more about just tools that help with code that helps with keeping the code clean before you actually run it. That, I guess, is like the general sort of understanding of static analysis tools, right?
Yeah. It's kind of any tool that's trying to learn about your program, but without actually executing it and observing what happens.
Is there an implication with respect to build times? Do certain sort of static analysis tools hurt build times? Is there a recommendation where you don't run these while you're compiling or while you're building? Because build times is something that usually has a direct impact on developers.
Yeah, this is kind of a big question. I think that, again, there's a wide variety of answers here. There's sort of very lightweight tools that essentially run in your IDE as you're coding. I'm sure you've seen it in Android Studio that, as you're coding, you see not just compile errors, but all kinds of other cool lints that are built into the IDE running as you go, right? So when you architect it that way, it's almost not slowing you down at all, right? You're just sort of, coding away and you're getting the errors as you go. And then, but just for about any tool that's kind of running as part of your build, I mean, it's doing extra work, so it's going to slow it down a little bit. You can mitigate this a bit by, if you have a build system like Bazel or Buck that's doing a bunch of stuff in parallel, then, sometimes you can be running the static analysis while you're compiling another module, and it doesn't really cost you that much in end-to-end time if you're building on, on kind of a beefy machine. But it's going to cost you something. So this is something I think every team, every developer kind of has to think about consciously. So the benefit is that, you catch these bugs early. So the question is, when do we want early to be? Do we want it to be when a developer is building their app locally on their machine? Do we want it to be sort of on CI before you can actually land your diff? All these static analysis checks have to pass. There are some decisions to be made. And I think, it's worth thinking holistically about developer productivity, and build time is just one part of that, right? So if your local builds are super fast, but then every time you put up a diff, you're getting 100 errors from your static analysis tools that you have to fix, you could argue that maybe it's worth sacrificing a little bit of local build time to just get those errors up front so that you don't have to go through this, process of making a PR and then waiting for a while and then and only then getting these errors, and then you have to context switch back.
In regards to, back to static analysis and the tools, people are still learning about this as we talk about it. Now, the tool, if you had to choose one tool that folks are probably most familiar with in regards to static analysis, would you probably say in regards to Android, would that be Android Lint? Is Android Lint, is that a static analysis tool? Yeah,
absolutely. I think that's probably the tool that in the Android world is the most familiar one, is Android Lint. It's quite a nice tool and has a lot of checks, and you can build your own checks on it too if you're a little bit ambitious.
Off the wall question here. I have no idea if you guys know the answer to this, but just something that just popped into my head. Do either of you know where the word lint came from in this type of tool, and why is it called lint?
Oh, I used to know this.
Well, this could totally be wrong because this seems like the obvious one, but I'll go with it. I mean, it isn't like it's with respect to cleaning, right? Like with lint, when you have like lint on your clothes, like you want to clean the lint off your clothes. And so I guess this is something along those lines. This could be totally wrong. I'm probably completely misinforming people, but at least that was my understanding.
Yeah, I think that sounds right. I'm trying to think back to what the original kind of linting tool was and who thought of that name, and that's something that's just escaping me at the moment.
Yeah, no problem. It's just one of those things where you just, after you've heard the term so many times, you use it in your regular vernacular, and then all of a sudden you just think about like, what does that word even mean? Why is it called that? And then it just kind of popped out. So, all right.
Yeah. Okay.
Now, for this, a lot of the static analysis that happens, we have some of it that's running in real time. Like you said, Android Lint is running inside the IDE. Android Studio is doing some other stuff, saying, hey, it looks like this variable is not used. So it kind of gives it a different color or underlines it or something like that. And we have these tools kind of built in. But that kind of, you said something very important, like you may have certain static analysis tools that slow down your build process, but catch important possible bugs later on. You have to figure out what that trade-off is. So it kind of makes me wonder, when and where should folks be performing static analysis? Should it be locally? Should it be on a CI server? Should only be in a build process? Should it be all of the above? Do you have a heuristic that you and your team like to follow?
Yeah. So I can tell you the Uber approach to this, which is maybe a little bit different than what a lot of other companies do. But we tried to build static analysis and linting tools where sort of the errors are very clear. So, it's not a puzzle as to how to fix this. It should be, pretty obvious, maybe require a little bit of thought, but not a lot of head scratching as to, can this really happen? Can it not happen? But then when we build those kinds of tools, we like to block the build on them, which means that if you have any errors coming out of these tools at all, we're not going to let you land the diff.
Oh, wow.
So we try to keep the code clean, completely green with respect to these tools. So this means that we definitely have to run the tools on CI, right? Because that's sort of the final check to make sure that things are all set. And then as much as possible, we try to give developers early feedback too and run them on local builds. This is where we make heavy use of error prone, which we haven't talked about yet. But error prone is a static analysis tool that's kind of built right into the Java compiler, and so it's just super easy to integrate checks in there and have them just automatically run as part of local builds.
Let's quickly just dive in, because I feel like before we get into error prone, because error prone is a beast of its own, and I know we have a bunch of questions there. But in general, you mentioned there are a whole bunch of tools that you run at Uber for static analysis. Can you tell us what the different tools are? I imagine Lint obviously is the obvious one. What are currently what is the tool chain of static analysis for Uber at this point?
So the big ones are error prone. And also Android Lint. We also do some kind of formatting checks and that kind of stuff using check style.
Oh, nice. Check style. Oh, okay. That's good.
On Android, I would say those are the major tools that we're running. Well, there's one other tool that we run right now around checking for bugs around use of threads with RX code.
Ooh, this is something I definitely want to
good.
ask you. Let's actually dive quickly into that because that is such an interesting topic.
What's the name of that tool? Do you have a name of it?
We don't have a particularly creative name for it right now. It's called the RX Thread Checker.
Love it. Yeah, can you tell us why we would need such a tool? Like what the problem is with like these issues, and yeah, if also thread checker is something that we can use.
Yeah, sure. The issue that we were trying to address was so RX makes it pretty easy to sort of run certain operations on certain schedulers, I think they call it.
Mm-hmm.
So you can say, observe on, the computation scheduler if you want to sort of run an operation in the background, or there's an IO scheduler for IO operations. But one key thing you need to do is whenever you're finally updating your UI after you've done all this computation, you need to be doing that on the main thread or on the UI thread on Android. Otherwise, you can potentially get this called from wrong thread exception at runtime because basically the UI is not set up to be thread safe and updated from multiple threads. So the rule is you should be on the UI thread when you're updating your views or whatever it is. And it can be easy when you're writing RX code and you're passing around observables all over the place to kind of forget to do an observe on main thread before you update your UI. Or maybe you're just not even sure about this observable, like what thread is it running on? Like you might think it's going to be on the main thread and then someone changes some other code and all of a sudden it's not anymore.
And it can get even more complicated too, right? For example, if you're like flat mapping, you're merging, you're splitting, you're doing like different sort of like observables, you're combining different observables and each of those run on different threads. At some point, it can get like very confusing to understand, well, eventually what thread does it run on,
Yeah, absolutely. We found that, even for pretty simple operations like delay, that, a lot of folks weren't aware that you do a delay and then all of a sudden the resulting observable is now on a background thread. So there's even little gotchas like that. So what this tool tries to do is basically using static analysis, it tries to do two things. First of all, it wants to keep track of what functions in your code are actually manipulating the UI. So we need to know what code is UI code and what code isn't, basically. And I can get into details, but that's at a high level. And then the other thing it tries to do is it tries to keep track for every observable, including those that get returned out of operators in the middle of an RX chain. It tries to keep track of what thread is this observable or what scheduler is this observable running on. And then once you have this information, at a subscribe call, you can say, okay, is the callback for subscribe touching the UI? And if it is, what thread is the observable on? And if it's not on the UI thread, then we can report an error and say, hey, you're subscribing to this observable that's off the main thread, but then you're going off and updating the UI. This is going to cause a problem.
Is this tool open source or is it available for us to use?
So the version that we're using right now is open source, so you can get it off of GitHub. So let me say a little bit about it though. So this tool is based on a really cool framework called the Checker framework, which was built by a group of academics, mostly out of the University of Washington. And it's a great framework. It's really great for building this kind of analysis. One caveat though is that it's also kind of a plugin to the Java compiler, just like error prone. And they don't at this moment play well together. Like you can't run them both within the same build. So we're actually working on building a new version of this checker that kind of integrates more nicely with error prone.
Very cool.
And that will probably be easier to integrate into a typical Android build. So we're hoping to get that out in open source, hopefully in the next few months.
Nice.
Once we have it, actually working. Our current tool is available. It just maybe not completely easy to integrate into your existing build, though. It's there, and we're very happy to help folks who want to give it a shot. and it should work fine. I mean, we're using it on every build for some of our apps. So
perfect. So we'll double link in that to that in the show notes. And I believe this is the Uber Research RX Thread Effect Checker repository.
Yep, that's exactly right.
Okay, folks can find a link to that in the show notes. You dropped a line or two about error prone. So could you tell us what error prone is now? Like, what is error prone?
Yeah,
sure. Error prone is this really fantastic framework that Google open sourced that lets you pretty easily add new kind of static analysis checks right inside the Java compiler. So basically, instead of using the compiler that comes with the JDK, you use the error prone version of the Java compiler, and it comes with all these extra checks for your code, and you can add in your own checks as well. The nice thing about this is we talked about build times and the impact of static analysis on build times. So since these checks run right inside the compiler, it actually significantly reduces the overall impact on build times, because as you're compiling the code, you've got to do a bunch of the work that these static analysis tools need anyway, right? So the Java compiler has already gone off and parsed your source code. It's figured out, for all the different, class names, what all the information is about it. It's done a bunch of the work that we already need to do. And then error prone can just piggyback off of that work and really quickly stick in, a few extra checks. As opposed to, say, Android Lint, which is a completely separate tool chain. And so it needs to do its own work to parse the code and resolve the names and that kind of stuff. So one advantage of error prone is that you can add new checks without impacting your build times too much. And of course, there's caveats there. If your check is doing something super inefficient, then it's going to slow down your build. And eventually, if you start adding hundreds of checks, that's going to add up. But for the most part, it's a way to add checks without impacting your build time too much.
Can you use error prone with Kotlin as well, or is it only Java?
Error prone right now is Java only. Yes, there have been, I think, initial discussions where folks will be like, it would be really great if there was an error prone for Kotlin as well. So there are discussions going on, but I don't know of an equivalent tool for Kotlin right now. So for Kotlin, I think Android Lint is still your best bet.
Got it. That makes sense. So error prone is basically like this platform that you can run other sort of like checks on eventually, I guess.
Yeah. I mean, it's just basically a set of lightweight APIs, and you can kind of plug in your check, and it gives you callbacks. So if you write a new check, you can just, write a new class and say, okay, I want to match on method calls. And then for each method call, if it's calling this method, I don't know, make sure that the first argument isn't passing certain numbers or something like that. It's very easy to write a check like that.
Excellent. Okay. If I remember correctly in our earlier conversations, I think it was before we hopped on the call here, there was a discussion that you had worked with and Uber had worked with or created something known as null away, which is also in the static analysis arena. Can you explain what null away is? If it's a library, maybe why I should use it and so forth?
Yeah, absolutely. So null away is actually a plugin check to error prone, but it's doing something a little deeper than most error prone checks do. It's basically bringing the kind of null checking that you get from the compiler in a language like Kotlin or Swift, and it's bringing that to Java. With null away, basically the developer is responsible for annotating any field or method parameter that can be null, right? You write an @nullable annotation on those things, and then null away goes and checks a whole bunch of stuff to make sure that you're using nulls in a safe way. So if you try to assign null to a field, it makes sure that field is in fact nullable. And then anytime you're dereferencing a variable, like calling a method or reading a field, it checks that either that variable can't be null, or if it can be null, that you did an appropriate null check before you did this dereference. So it's I think the Kotlin compiler is doing very similar checking. It's just bringing this kind of checking to Java.
So I guess like the idea here is you probably don't need something like this for Kotlin because like you inherently have those annotations, and Kotlin does like, I mean, this was one of the biggest selling ticket points with Kotlin, right? That it actually is like safer because it makes you like handle that null. So the point is like if you have Java code in like your apps, which most developers unfortunately still do, like with their Android apps, this would be a super useful tool to sort of like help with making sure that you don't like necessarily mess your build systems there, right?
Yeah, absolutely. I mean, any place that you're still using Java code, I think if you really want to get rid of null pointer exceptions as much as possible, then using null away is a really good way to go.
Got it. So here's a question I have. I do know there's a linting tool, like when you add the nullability annotations, there's a linting check that tells you like with warnings that, hey, you might be using like a null sort of, you might be calling this on like a null reference. How exactly is null away like different from that, if that makes sense?
Yeah, I think that at a high level, null away is probably more thorough. So from what I know, the existing linting tools might check certain cases around, say, if it sees return null in a method, maybe it checks that you annotated that return value, the return of that method is nullable. And it catches certain cases, but null away tries to be more exhaustive in what it checks. And I think one interesting area here is stuff like method overrides, right?
Oh, interesting. Can you talk a little about that? How that makes it interesting, like how that makes it a little different?
Sure. So let's say you've got an interface that declares a method and the parameter is nullable, right? So that means that anybody who implements this interface and they implement that method, that method should be able to take in null as a parameter, right? So if you have an implementation of that interface and the method actually doesn't declare its parameter as nullable, then null away will actually immediately complain and say, hey, you're overriding this method that has a nullable parameter, and this override is trying to make it non-null. So there's a potential problem here. And there's a similar kind of reverse thing for return values. So it's that kind of checking. I don't know if the other tools are doing it to quite that level. I think the ambition of null away is to try to just basically eliminate null pointer exceptions as much as possible. It has some gaps compared to Kotlin, like with generic types. We don't have full support for generic types and writing nullables on generic types and that kind of thing. But in practice, it's been okay, at least at Uber. So what we do is we actually, keep an eye on crash reports from the field. And if there's a null pointer crash that actually happened, then we immediately dig in and say, oh, was there a bug in null away, or is this a known gap? We've pretty much got it down to a very small number of null pointer crashers.
That's amazing. I was going to ask, so does that basically mean, have you seen a standard, like a steady trajectory of your null pointers going down, like the error crashes due to null pointers going down as you've added this tool? I mean, did the tool come out because this was a problem? I guess that's my question.
Yeah, the history is kind of interesting. So there's another tool that I think is quite cool for Android that I haven't mentioned yet. Actually, it's a tool called a framework called Infer that was put out by Facebook.
Oh,
and that has all kinds of interesting checks. I recommend it, and it has in particular a tool that's pretty similar to null away built in, and that was being used at Uber. Even before I joined, and it did help to get null pointer crashes way down in the Uber apps. The issue was that this is a completely separate tool chain. It's not built into the Java compiler like error prone, and it was actually having significant impacts on build time. and kind of affecting developer productivity. So the thing that I started working on when I got to Uber was, seeing, could we build the same kind of tool, but integrate it right into the compiler? So that's basically what Nullaway is. I mean, it has some other differences with Infer in terms of how strictly it checks things. But the main difference is that it's built into the compiler. And so actually we have it turned on by default on every single build. So even if you're building your app locally, it's running, the compiler is running with Nullaway enabled. So you're catching the errors kind of immediately. And it's kind of hard to do that level of checking without some kind of compiler or IDE integration.
That makes sense.
Makes sense. So we've covered quite a bit about static analysis, some of the the tools from the RX Effect Thread Checker, Error Prone, Nullaway. We've talked a little bit about Android Lint. Now, what a lot of folks end up doing after the show is kind of taking away something and say, hey, I want to go try this out, or I want to go implement this in my app. And if you were to give some advice to the listeners of the show, what would you say would give the kind of the 80-20 benefit of static analysis after the show? What steps should they be doing? Should they be enabling something? Should they use a certain tool? What would you recommend someone who wants to get the most bang for their buck right after the show?
Yeah, that's a great question. I think that, because it has such good integration already, that Android Lint is a great place to start. I think I have two thoughts here. One is I am a fan of this philosophy of, picking some checks that you care about and then blocking the build on them. I think it has a lot of benefits in terms of just, expectations, particularly that new developers can have when they come to a code base about what kind of issues will be there and what won't be. And then the other thing about lint errors is if you have a linter on, but you can kind of optionally ignore the warnings that it's spitting out, is that, down the line, it creates issues, let's say, where, you're editing someone else's file, you put up a diff and you get all these errors, and, it's because someone else ignored the problems. It gets hard. It can get hard to clean that up. So I think, it can actually be quite nice to sort of say, okay, we care a lot about these problems. Let's block the build on these issues and then spend some time and get everything cleaned up. And it doesn't mean, there are ways to suppress warnings. There's a suppress lint annotation, I think, for Android Lint, or suppress warnings. And we don't say never use those, right? Sometimes that's appropriate, but actually addressing every single issue so that when you run the tool, your code is clean.
For what it's worth, we actually had a similar kind of issue because in the early days, we did sort of not necessarily care, at least in one of the apps for Instacart, we didn't care about the lint warnings. So it got to yeah, exactly. It got to a huge sort of I think we were at 100 or 200. So, and the problem is we are not necessarily going to be able to just say, okay, I'll spend this week and get all the lint warnings down because, or just the build warnings down. So what we did is in our CI system, we basically added this check to make sure that even if you commit new code, you never increase the lint. So the builds would get blocked if you didn't, if the lint warnings ever crossed. So if you were at 102 or something, if anyone added code that got the lint warning to 103, it would fail the build, right? And then what we did is in order to tighten it incrementally every sort of few weeks, we would reduce that count, right? So that count would automatically just, and so now whether we like it or not, someone's build is going to fail, and so someone has to take care of it. It is a tad bit aggressive, but it worked amazingly well because our warning count went down pretty fast.
I like how you did that.
Yeah, it's worth just trying to get a handle on these things. And if I can mention one other thing real quick,
please.
There's a lot of power in building your own custom checks customized to your own code base. I think Android Lint makes this pretty easy. Error Prone makes this pretty easy. So I would suggest, thinking about, is there some check that we want to do on our own code, and then just going off and trying it out. I don't know. And often it's just pretty enlightening just to read the source code of existing error prone checks. Or probably you can read the Android Lint checks too and just, see how they do it. It's actually surprisingly simple to build a check. And we have a lot of custom checks, just one-off little error prone checks at Uber, and we get a lot of value out of those. So I think it's definitely worth investigating. If there's some kind of bug that's, custom to your frameworks that you're using at your company, where it just comes up again and again and again, I'd say, think about whether you can just quickly build a lint or an error-prone check to catch that, and then that way you don't have to worry about it anymore. You don't have to think about it when you're doing code review. It's just, the compiler and the tooling is taking care of that for you.
Can you give us a quick example of like one of these custom lint checks, just so like people can understand like what an example would be for this?
Sure. So a simple example is just sort of APIs that we don't want folks to be calling anymore, or at least maybe not calling from certain parts of the code. So that's probably the power, right? Like if you have some API and you want to say, okay, it's okay to use this in this type of module, but for these other modules, we don't really want to be calling this API, say because it's really expensive to call. So we don't want to be calling it from certain types of classes. That's actually quite easy to build a custom lint check to say, don't call this method if these other conditions are true. So that's one that we use quite a bit.
So if I want to write a lint check saying no more async tasks in my repository, is that possible? You think I can write a lint check for that?
Yeah, almost definitely. You could write that lint check, but you can make it finer grained, right? You're writing code to decide when you should and should not use, say, async tasks. You can look at what method am I in, what class am I in, what does it inherit from, all these kinds of things. To try to make a finer grained decision about what you want to allow and not allow.
That makes sense. But for async tasks, the answer is there's never a good reason.
Just never.
I'm just kidding. But very cool, very cool. Are there any other tools before we start to wind this down that you would like to point our listeners to?
One tool, I guess, that I'll plug because we're looking into it is, I mentioned Facebook Infer, and they've got a cool tool in there called RacerD, which can actually statically detect data races in your Android code.
Oh, wow. Huh.
And we've been testing it out, and it looks pretty promising. So that's a cool tool that I think folks might want to check out, because these data races are pretty brutal to debug. Once you've got an issue coming in from production, then even figuring out it was a data race can be a hard problem. So that's one that's kind of on our horizons that we're looking very seriously at deploying in the near future.
Fantastic. Manu, thank you so much for spending the time with us and talking about these things. This is super interesting.
Thank you.
I think you've given us a lot to go. We'll make sure to add links, because you mentioned a whole bunch of these tools that I think would be amazing. We'll make sure to add a link to all of these in our show notes, so folks can always reach out and use this as a reference.
Yeah, no, thanks a lot for inviting me. I had a lot of fun.
If folks want to reach out to you directly, or if they have questions that they felt we didn't get time to cover, or they want to dive really deep and ask details, what would be a good place to do that?
Yeah, I think probably Twitter is the best place to reach me. I'm raking leaves on Twitter.
Nice.
Just ping me there anytime. I'm super happy to answer more questions about our own tools or about static analysis in general.
Fantastic. Thank you so much for joining us today, Manu.
Thank you so much.
Okay, yeah, thanks again.
All right, folks. Thank you so much for listening. We will catch you in the next episode. Fragmented is hosted by Don Felker and me, Kaushik Gopal. We edit and produce all the episodes here on Fragmented. Sarah the Amazing Jackson from the Spec Network helps with production assistance and wraps our final mix. Our theme and ad music is by the national recording artist Blueprint from Weightless Recordings. You can find more Fragmented episodes at fragmentedpodcast.com. Thanks for listening, and we will catch you in the next episode.